We will start our DApp by writing the smart contract that act as a backend logic and storage. First, we go to the extension and search for the Solidity package. Install this package will help syntax highlighting and snippet for Solidity code in Visual Studio. Now, create a new file named Adoption.sol in the contracts directory. We will write pragma solidity caret 0.5.0. This is the minimum version of Solidity required is noted at the top of the contract. The pragma command means additional information that only the compiler cares about, while the caret symbol means the version indicated or higher. We will create our first contract now by writing contract adoption. Solidity is a statical type language, meaning data types like string, integers, and array must be defined. Solidity has a unique type called an address. Addresses are Ethereum addresses stored as 20-byte value. Every account and smart contract on the Ethereum blockchain has an address and can send and receive Ether to and from this address. We will add the variable on the next line after the contract adoption. Address 16 public adopters. Here we have defined a single variable adopters. This is an array of Ethereum address. Array contains one type and can have a fixed length. In this case, the type is address and the length is 16. You will also notice adopter is public. Public variable have automatic getter methods. But in the case of arrays, a key is required and will only return a single value. Now we will write a function to fill the address in adopters array. Function adopt passing parameter uint pet id public returns uint. In Solidity, the types of both the function parameter and output must be specified. In this case, we will be taking the pet ID and returning an integer. We will check to make sure pet ID is in range of our adopters array. Array in Solidity are indexed from 0, so the ID value will be between 0 and 15. We use the require statement to ensure the ID is within the range. Require pet ID is greater than equal to 0 and pet ID less than equal to 15. If the ID is in the range, then add the address that make the call to our adopters array. The address of the person or smart contract who called this function is donated by message.sender. Adopters pet ID is equal to message.sender. Finally, we return the pet ID provided as a confirmation. Return pet ID. Now we are going to write second function retrieving the adopters. Array getters return only a single value from a given key. Our UI need to upgrade all the pet adoption status, but making 16 API call is not ideal. So our next step is to write a function to return the entire array. We will make function get adopters, make it public. The view keyword in the function declaration means that the function will not modify the state of the contract. Since adopter is already declared, we can simply return it. Be sure to specify the return type, in this case, the type for adopters, as address array memory. Memory gives the data location for the variable. Now that we have written our smart contract, the next step are to compile it. Solidity is a compiled language, meaning we need to compile our Solidity to bytecode for the Ethereum virtual machine to execute. Open the terminal and we will write Truffle compile. You should see the output similar to this.